This is an AIPMT 2015 question from friction concept. The problem is like this. A block A of mass m1 rests on a horizontal table. Light string is connected to it, passes over a frictionless pulley at the edge of the table, and from that another block of mass m2 is suspended. Let me stop there. It's a very long sentence. Let me explain what he has given for you. Let me try to draw a diagram for that. There is a horizontal table on which block m1 is resting. Light string passed over a frictionless pulley, and at the second end of the string there is another mass m2 is suspended, right? The coefficient of friction is given for you on the horizontal surface. When the block A is sliding on the table, what is the tension in the string is, right? So it is moving. What happens when it is moving? Let's try to understand that, right? So when the block A is sliding means this is also moving down. So this is coming down with an acceleration, so that this will move towards the right with an acceleration. Let's write down what are the forces acting on each of the body. On this body, its weight obviously acts in downward direction. This string becomes tight and generates a tension towards the point of suspension, that is towards this smooth pulley. Similarly, the same tension is forwarded in the upper part of the string, that is also towards the pulley point of suspension. Not only that, because this surface is rough, as this tension is trying to move the body forward, a kinetic frictional force is generated in the opposite direction. Now I can draw free body diagrams for each of them and write equations of motion, right? So I can write first of all for M2, as the motion is downward, F resultant, that is M2A, equal to, as the block is sliding down, force in the direction of motion shall be treated as positive, against the motion shall be treated like negative. M2G minus tension. That's F resultant for the block M2. Similarly, for the block M1 on the horizontal surface, as the body is moving towards the right, force in the direction of that tension has to be treated like positive. Frictional force is acting against it, right? So tension minus frictional force equal to M1A. Frictional force is mu into normal reaction. M1G is the weight acting downward on the floor. So normal reaction is the same. So mu into M1G equal to M1A. These are the things that I have calculated, right? From here, I need to calculate the tension. Calculating the tension directly is a bit difficult. First, let's calculate acceleration so that I can get the tension later. If you notice little carefully, in one equation there is minus tension. In another equation there is plus tension. So the simplest way of solving this problem is add both of them. Adding equation number 1 plus 2 cancels the tension so that I'll get an acceleration. Look at that. On the left hand side M2A, on the other right hand side M1A. So when you add both of them, M2A plus M1A on one side. On the other part of the equation, M2G minus tension in the first equation, adding, that means plus T minus mu M1G. So these tensions get cancelled. So acceleration of M1 plus M2 equal to, G is common for both of them, M2 minus mu M1 of G. That implies acceleration of that system is M2 minus mu M1 by M1 plus M2 of G. Once after getting the acceleration, now I can calculate the tension. How can I calculate the tension? I can simply substitute the value of acceleration in equation number 1. So what we can say? Yeah. From equation number 1, M2A equal to M2G minus tension. So tension becomes, take this tension to the other side and get this M2 to this other side. Tension equal to M2G minus M2A. That is M2 of G minus A. But I know the value of the A already. I have derived an equation for that. Just substitute that. M2G minus acceleration means whatever the equation that we have derived. How much is that? M2 minus mu M1 by M1 plus M2 of G. That's the derivation. That's the equation that we have made. Let us simplify this. M2 is outside. G is common in both of them. 1 minus what is remaining? M2 minus mu M1 by M1 plus M2. This has to be simplified further. M2G of LCM is M1 plus M2. Being a numerator is 1. Here also I will get M1 plus M2 minus M2. Minus of minus becomes plus mu M1. M2 gets cancelled. So what's the remaining answer is M2G M1 plus mu M1 by M1 plus M2. I can take M1 common in the upper part, numerator, M1 M2G of 1 plus mu by M1 plus M2 is the tension. You can look into the options. What is that option? Yeah. Option C, M1 M2 of 1 plus mu. Of course, he called mu as mu k. So that can be taken like mu k. G by M1 plus M2. Option C is the answer for the problem. So solving this problem, though looks like little lengthy, is actually quite simple once if you know how to draw free body diagrams and equations of motions. As it's a simple problem, I have not drawn the free body diagrams, but I have written directly equations of motion. How do you write equations of motion? We shall identify in which direction the system, which body is moving. Force in the direction of motion shall be treated as positive. Force against the motion shall be treated like negative. Their resultant becomes resultant force of that body. Follow that simple rule, solve, you will get an answer, right? You can relook into the video once again if you have not got it clearly at any part of it. Even after that, if you still have something to ask, you can post a comment so that I'll clarify it for you. Thank you for watching.